Hello and welcome back to another day of math with Miss Murthy. Today's lesson is lesson 1.7 in revealed math. As usual, you can see the page number on the bottom. It's page 57 that we're starting with today. And as is our usual custom, I want you to pause and do all the talk about it, think about it on your own. Also, after every example, there is a check problem. You should be pausing the video and solving the check problem on your own, and we will review it in class. Okay, also pause and solve the warm-ups on your own. So today's lesson is on understanding rates and rate unit rates. So we will be comparing quantities using unit rates. There you go, that's the solutions. All right, now Luciana ran 4 laps around the track at her middle school in a total of 6 minutes. Suppose she ran at a constant speed, which means the speed that she ran with at the beginning of the race as well as at the end is the same, right? The bar diagram on the right that you can see here represents the relationship between the number of minutes and the number of laps. You can see that it shows us 4 laps and 6 minutes. Now the ratio of the number of minutes to the number of laps is 6:4. Because the units, which is minutes and laps, are different, this kind of a ratio is called a rate. A rate is a special kind of ratio in which the units are different. In this case, you can see the ratio 6:4. It has the associated rate of 6 minutes for 4 laps. So to find the number of minutes per lap, we find the value of each section. 6 divided by 4, which gives us 1.5 minutes. So Luciana ran at a rate of 1.5 minutes per lap. Now this rate, 1.5 minutes per lap, is called a unit rate. So in other words, a unit rate is a rate in which the first quantity is compared to 1 unit of the second quantity. The phrase per is used to describe unit rates. It means for each. So in this case, you can see Luciana ran 4 laps in 6 minutes. But if you want to find out, rewind. If you want to find out how many laps she can run in 1 minute at this same rate, our bar diagram is now going to change, right? Our bar diagram is, we have 6 sections of 1 minute each, and she ran 4 laps in those 6 sections. So the ratio of number of laps to the number of minutes is 4:6 because she ran 4 laps in 6 minutes. So this ratio, which is 4:6, has an associated rate 4 laps in 6 minutes. And to find the number of laps per minute, we find the value of each section. So you can see the value of each section is going to be 4 divided by 6. 4 laps divided by 6 minutes each, or 6 minutes total, which gives us 4 by 6, or in other words, that's 2 by 3. So Luciana ran at a rate of 2/3 lap per minute. So this table now summarizes ratios, rates, and unit rates, okay? And you'll see on my slides, it's split up into multiple slides. So a ratio is a comparison between two quantities, in which for every A units of one quantity, there are B units of another quantity. So if you see, you could do 6 laps to, there's a typo over here. This should be minutes. 6:4, or 4 laps in 6 minutes. In the case of a ratio, the units can be the same or different. Now when we come to a rate is a special kind of ratio in which the units are different. Okay, like 6 minutes for 4 laps, or 4 laps in 6 minutes. And a unit rate is an even further special case. A unit rate is a rate in which the first quantity is given for every 1 unit of the second quantity. And again, the units are different in this case. Let's take a look at example 1 on page 59. A scientist studying hummingbirds recorded that a hummingbird flapped its wings 1,590 times in 30 seconds during normal flight. Assuming a constant rate, how many times did the hummingbird flap its wings per second? So What are we going to do here? We're going to use a first method. We could use a ratio table. So let's create a ratio table with the given information. Number of wing flaps, number of seconds. We know 1590 in 30 seconds. So to find out the rate per second, we know that we have to divide by 30. So that means we're dividing the other quantity also by 30. 1590 divided by 30 is the same as 159 divided by 3, which gives me 3 goes 5 times in 15, and then 3 goes 3 times in 9, so that's 53. Okay. Now, the second method that we could use is to use equivalent rates. We would write and solve an equation that states the two rates are equivalent. So let's use S to represent the unknown number of wing flaps per second. So we know S is to 1 because we're looking for per second. S is to 1 equals 1590 to 30. Again, to go from 30 to 1, you divide by 30. So you're going to divide the numerator by 30. So you can see that 53 is to 1 is the same as 1590 to 30. So the hummingbird flapped its wings at 53 flaps per second. Pause and do the check problem on your own, please. There you go. All right, let's take a look at unit price. Right, where do we see a unit price? We see it in stores where we are buying usually grocery items. So a grocery store sells a 6-ounce container of yogurt for 78 cents. The store also sells a 32-ounce container of the same yogurt for $3.84. So to determine which is a better buy per ounce, we find the unit price of each item. The unit price is the cost per unit of an item. And you can use what we know about unit rates to find the unit price. Let's take a look at how we're going to do it. So for our 6-ounce container and 32-ounce container, let's put them on two sides of a paper, right? And then we're going to create equivalent ratio tables for both of them. And we scale backward to find the price per ounce, because that's the only way you have something that is the common between the two containers that you can compare. So you can see 78 cents for 6 ounces. It means you need to divide it by 6. So that gives you 13 cents per ounce. For the 32-ounce container, it was $3.84 for 32 ounces. So that tells me that my division factor is 32. And therefore, I'm going to also divide 3.84 by 32, which gives me 12 cents. If you compare the two, you can see that 12 cents per ounce is less than 13 cents per ounce. Therefore, the 32-ounce container of yogurt is the better buy because that unit price is less. Let's take a look at this example. For Carolina's birthday, her mother took her and 4 friends to a water park. Carolina's mother can pay either $130 for a 5-pack of student tickets or $28 for each individual student ticket. Which ticket payment option has a lesser unit price? So we are already given the unit price if you're buying the tickets individually. So all we need to do is find the unit price for the 5-pack of student tickets, right? How do we do that? We have to scale back because we know the price for 5. We want to find out the price for 1. So make your equivalent ratio table. You have 130 for 5. So you divide both entries by 5 to give you the unit rate or the unit price. In this case, it's 130 divided by 5, which is $26. So you can see that the individual ticket costs you 25, whereas when you buy a pack of 5, it's 26. If you're going to use all 5, then buying the 5-pack makes sense because that has a lesser unit price. I want you to pause and do this check problem on your own, please, in your books. There you go. All right, that's all I had for today. We're going to take a look at this apply problem in class tomorrow. Ciao.